Welcome to Hartman Math. This is lesson 4.7, graphing cube root functions. So here's our parent function, f of x equals the cube root of x. We're going to do a table of values. We're going to plot points. We're going to see what shape those points create. Unlike our previous lesson when we were doing square root, we really don't have any restrictions here on x. Because this is an odd root, we can take a cube root of negative numbers. So keep that in mind as we pick some x's. We do want to pick x's that would be easy to take cube root of. So if we think of a previous lesson where we're listing out cubes, some of those might want to be in our list of x's, but 0 is a good place to start. We can take the cube root of 0. The cube root of 0 is 0. And the first in our list of cubes, when we listed them out in the previous lesson, was 1. So the cube root of 1 is 1. And then the next perfect cube was 8. And the cube root of 8 is the question, what number would we cube to get 8? That's going to be 2. And then we can also do these negatives. So the cube root of negative 1 is negative 1. And the cube root of negative 8 is negative 2. Those are going to be the points that we plot. So left 8 down 2, left 1 down 1, 0, 0, 1, 1, 8, 2. So we want to fit our curve through these points. It's very similar to the x to the third parent function, but that went this way. This one just goes kind of sideways. So we do have an inflection point at the origin. It's going to bend this way until we hit the origin, and then it's going to bend the other way. Careful with the drawing. It still has to go down without bending the wrong way. It still has to keep going up. So it can't ever go horizontal. That's one thing you're looking for. Let's see if we can analyze the key characteristics of the f of x equals cube root of x parent function. Looking at our graph, what's the domain? Goes left forever, goes right forever. So negative infinity to positive infinity in interval notation. What's the range? A little bit harder, but it does go down forever, slowly. It does go up forever, slowly. So our range is also negative infinity to positive infinity. On what domain interval is it increasing? Well, if we travel along from left to right, it's always going up. So from negative infinity to positive infinity. And if it's always going up, then it can't ever be decreasing, and it can't ever be horizontal or constant. Where do we touch or cross the x-axis? 0, 0. Y-intercept also 0, 0. Where is it positive? We're above here. So starting at 0, going to infinity. Where are we negative? Where is the function below the x-axis? That's this section, starting at negative infinity until we get to 0, always moving from left to right. And our end behavior as x approaches positive infinity, as we go right on the graph, we go up very slowly, but keep going up forever, positive infinity. As x approaches negative infinity, we're going left on the graph. It keeps going down and down slowly, but down forever to negative infinity. So let's graph, where here's our general function, again with the normal things that we see in our functions. With the a, we know what that does. The h and the k. For our square root graphs, that gave us our initial point. For cube root graphs, it gives us the inflection point, or you might say the center point. So example number 1, graph g of x is equal to cube root of x plus 1 minus 3. Our h and k give us the inflection point, -1, comma, -3. And we can put that here, -1, comma, -3. And then we're going to look to an a value, which is an invisible 1. So we're going to go right one, up one. And do the exact opposite. Left one, down one. As we do the transformations, we need to have a minimum of 3 points. And then be careful on shape. We don't want the one going this way. That would be x cubed. We want cube root, so we want the one that kind of snakes to the side like this. Careful again on shape. It's going to bend this way, hit our inflection point, then bend the other way. Does not go horizontal, doesn't come back up on this way, doesn't come back down this way. Be real careful on your shape. Finding our intercepts, again practicing like we did in the previous lesson. For x-intercept, set the function equal to 0. And we're going to solve for x. So first thing we're going to do is undo the -3. We'll add 3 to both sides. Since the +1 is inside the root and protected, the next thing to do would be to undo the root. So this is a cube root. The inverse would be cubing both sides. So we will do 3 to the 3rd power, we'll cube this, meaning that we'll just get the x plus 1. That is 27. We'll need to subtract 1 both sides, so we get x is 26. 26, comma 0 is where we will eventually, as we keep coming up, hit the x-axis. The y-intercept, you just plug in a 0. 0 plus 1 is 1. The cube root of 1 is 1. Subtract 3. Oh, we even see it here anyways at 0, comma, -2. Example number 2, h of x is equal to -2 cube root of the quantity x plus 4, leading to our inflection point at, here's our h, -4, comma, nothing out here, so plus k, that would mean an invisible plus 0. So -4, comma 0 is our inflection point. We'll plot that. To get our next point, we're going to go right 1, and our a is -2, so we're going to go right 1, down 2. And on the other side, we'll just do the opposite. We'll go left 1, up 2. And again, shape, snake-like, don't go up the page. We want to go sideways on the page for our cube root graph. X-intercepts, I think we see it. We see where we're hitting. I think it's going to be the -4, comma 0, but let's practice the algebra. See if we can just verify that. Set the function equal to 0. Nothing out here to get rid of, so we'll need to get rid of the -2. It is multiplication that's happening between the -2 and the root. So to undo multiplication, we'll divide both sides by -2. 0 divided by -2 is still 0. Now we can undo the root by raising to the 3rd power. That's the inverse. So we'll raise to the 3rd power, raise to the 3rd power. 0 to the 3rd power is still just 0. So if we subtract 4, we're getting 0 minus 4 is the -4, so we can't verify that. The y-intercept, plug in a 0. 0 plus 4 is 4. 4 is not a perfect cube, so we'll just leave it in that terms of 0, comma, -2 cube root. So for our y-intercept, we'll just do h of 0, substitute in a 0. 0 plus 4 is 4. 4 is not a perfect cube, nor does it have any factors that are besides 1. Doesn't help. So we're just going to leave that as cube root 4. So -2 cube root 4 is our value 0, comma, -2. Cube root 4 is the exact value. We can kind of see that the decimal would be somewhere just a little bit below -3 if we needed to approximate. All right, here's a your turn. You're going to graph d of x. Pause the video here until you're ready to check. All right, our inflection point is going to be h coming from inside the root. I don't see anything there, so x must be the same thing as x minus 0. 0, comma 3. 0, comma 3 is our inflection point. Then from there, we're going to go right 1. A is a half, positive, so we're going to go up a half. And then the left side will just do the exact opposite. Left 1, down a half. And again, make sure it's kind of going sideways. Got the right shape for our cube root graph. We do need to find the x-intercept. So we'll set d of x to be 0. And we're going to solve. So we need to undo the plus 3 as we isolate. Undo addition, subtraction first typically. We're going to subtract 3 both sides. We need to get rid of the half. It is multiplication here. So we want to maybe think divide by a half, but maybe safer, multiply by the reciprocal. So to get rid of a half, we'll just multiply by the reciprocal of 2. That cancels it out. So that's why we're going to get -6 on the left. And now we can undo the root by raising to the 3rd power, since it's a cube root. Make sure we have parentheses around the -6 to do that. And that's going to end up being -216. So it's going to slowly come down. It's going to be a ways out there where we're going to come and actually run into the x-axis at -216, 0. The y-intercept, I think we've got at 3, 0, 3, so let's just check that out. If we substitute in a 0, cube root of 0 is 0. Half of 0 is still 0. Add 3, we got 3. So we've got a confirmation of our y-intercept being 0, 3. That's it for today. I'll see you next time.